Exactly a year ago, we had Ryan Whirl on the show talking about WarpStream, which is a company that had executed a very cloud age trick. You take a database or a data storage tool, in their case Apache Kafka, and you copy the same idea, but you replace the storage layer with S3. Why would you do that? Because you'll lose something in latency, but in return, you get cheap, automatically replicated, practically infinite disk storage. From a technical point of view, that's an interesting trade-off. What took me by surprise is quite how appealing it turned out to be as a business idea. Less than a year later, they sold that company for, reports vary, but around $250 million. Billion with a B. Which kind of makes you wonder, are there any other Apache projects you could copy but use object storage? That's a question for another day. The question for today is, given those kinds of numbers, it's not really surprising there's a wave of other companies doing the same Kafka but on S3 model. It's clearly big business. What is surprising is that one of them is trying to get that feature merged back into the original open source project as an open source feature. And that raises some questions. First up, why would you do that? Why would you give up what seems to be a big business competitive edge? It can't just be altruism. Then you've got the host of technical questions. How do you do it? How do you take a clustered, replicated, database-like thing and then retrofit a completely different way of storing the data without breaking backwards compatibility? And even if you can crack that, then you've got the socio-technical problems of getting a major feature change merged into a long-established Apache formalized project. There are many hurdles. Joining me to be grilled on those hurdles, on the why, how, and with whom questions, are two people from the company attempting to do it, Filip Yonov and Josep Prat of Aiven. Now, before we begin, you need to know this episode has been sponsored by Aiven, so let me tell you what that means and what it does not mean. They haven't had any control over the questions. They didn't suggest questions. They didn't get a list of questions beforehand. I think if you're a regular here, you know these episodes don't have scripted questions. It's the death of conversation. It's never going to happen. I did offer them a review copy after we recorded, but before this was published. They declined, but I did offer. The main change is I let them choose the publication date. I've got about 5 months worth of episodes recorded. Sponsorship lets you jump that queue. I'm comfortable with that. I hope you are. But the only way you can really judge is if we get started, so let's do that. I'm your host, Chris Jenkins. This is Developer Voices, and today's voices are Filip Yonov and Josep Prat. Joining me today are Filip and Josep. How are you doing, gentlemen?
Pretty good.
Yeah, quite good.
I'm really going to pick your brains on this one, so I hope you're feeling sharp. There's a lot to get into. So I was thinking about this, right? I was trying to dig up in my memory Kafka, replication, persistent storage, all this stuff. I was trying to go through in my mind how it works. And I think it's pretty similar to what you build for any distributed replicated system, right? In that, here I am, I would like to write some data. And I want to write it in a way that's fault-tolerant and durable. So I have 3 machines, let's say, and one of them is the leader. I talk to the leader, I give it some data. It writes that to its own disk and to its followers. And when they acknowledge, it acknowledges back to me, right? And then that's durability because I've got 3 copies. If one of them fails, there's a new leader election, so that's high availability. And the only thing I've missed out, I think, is how do I find the leader? So there's some brief conversation beforehand where I say to the coordinator, who's the leader? That's who I'll talk to write my data. Have I got that roughly right?
Pretty much right, yes.
Good, right, okay.
I mean, the only thing you can add as well is if you want to have the durability, you might want to put these 3 different nodes in different availability zones. So if there is a fire on the data center, you might want to have only one of them going down instead of the 3 of them.
Right. Yes. Yeah. If I dream of running a company large enough that has that problem, but there are plenty of
I mean,
them.
if we go theoretically speaking,
Yeah.
that's what you would like to do, right? You would like to have the 3 nodes that keep each copy of that data that you're sending in complete isolated areas in the world, or at least that if there is any catastrophe, it doesn't affect all the 3 of them at the same time.
Yeah. Yeah. Okay. So, but that setup I've described already exists today in Kafka. So I think the first question has to be, and I'll address this to Filip, what's wrong with that? Why meddle with it?
Well, I am less technical than Joseph, so I'll actually take a step back and how do I explain myself the replication today? So how the hell those megabytes are being spread around to achieve this high durability? So basically, what we just described is fine if you're sitting in a single availability zone in the cloud. It doesn't really actually cost anything to move data there. But the moment you actually want to distribute your brokers in 3 distinct availability zones to achieve maximum durability, you effectively start paying the replication 4 times. So the model is basically the following. In the default 3-zone distribution setup, data crosses availability zones through those 4 paths. So let's take it. Producer to leader. You already mentioned that you need to kind of like connect with the leader.
Mm-hmm.
Then the leader to the first follower availability zone, which is kind of like the broker. Then you have leader to second follower, and then leader to consumer. So effectively, if you turn that hose up, it's almost like a multiplication factor on your bill, because in AWS, which is one of the more taxing clouds, we are talking about data in and data out. So these 4 times are getting taxed 1 cent each on egress and egress. So you can imagine that this kind of like starts blowing up very quickly.
And there is a very significant difference in price between data within an availability zone and across an availability zone.
Absolutely, yes.
Yeah.
One of the things which we kind of discovered, and by the way, why we discovered it, because Aiven is one of the oldest managed Kafkas on the cloud, and this didn't really exist back in the day when they were setting up Kafka to begin with. We discovered that actually the inter-AZ tax or fee in AWS is, even though it's a list price of 1 cent, it is actually counted twice on data in and data out. And obviously, to achieve the durability guarantees, we always cross. So we always ingress and then egress.
Right. So are we then talking about 8 paths? Do I pay? No, I'm paying once per hop and I get the response for free at least.
Yes.
Okay, yeah, just checking.
Yes. Yeah.
Okay, so this is mainly about the sheer operational costs once you split over different availability zones.
Yeah.
I see how that would justify a colossal engineering effort, which I want to get into. That's where the technical juice is.
Yeah, so basically, if we actually start taking a look at the motivation. So basically, when we talk about the motivation, it all started with a white paper I wrote internally at Aiven 2 years roughly ago, where we were kind of studying the cost and the footprint of our fleet, like understanding how our costs of Kafka and the FinOps was actually panning out, simply because we wanted to understand the real gross margin of each of our customers, right? So this is like how it started. The real motivation behind it was economic. At this time, we already started seeing the newcomers. For example, WarpStream was one of the first companies out there which kind of proposed a new design, a fundamentally new design. And this kind of coincided with the numbers we were running. So it was a very much an economic motivation. Let's make our Kafka cheaper. Can we grow our gross margins? But the more we dug into with the engineering team over the last year, we found that actually by delegating the replication flow or this replication mechanism, which we just discussed, the more benefits we started uncovering, to the point where I found myself the other day talking about Diskless Kafka. Cost was only priority number 3 and 4 in most of those conversations. It's kind of like after the fact. People were far more interested in the elasticity and some of the other ergonomics, which kind of like this delegation produces. Yeah.
Okay, yeah, because we've all had that problem where disks fill up, right?
Yeah.
And that is another nice, because I'm going to say, just for the record, I mean, the word serverless I used to get stuck on, and I feel myself getting stuck on the word diskless again. But this is the point is not that there's no disk. The point is the disk is someone else's problem.
Correct.
When it fills up, I don't have to worry about it.
Yeah. The problem with serverless was not that I'm not running on any server, right? It was the server is not my problem anymore. It's somebody else's. It's the same as cloud and computers. They are not my computers anymore, but they are computers or data centers. So it's the same thing with disk. Diskless doesn't mean there are no disks whatsoever, but rather you don't need to worry about disks anymore.
Yes, and disk headacheless doesn't trip off the tongue as easily, right? Yeah.
It's a funny story how actually we came with the name, Joseph. Maybe you can tell this one.
Okay, so we had a code name for this project internally. And the code name, knowing that Apache Kafka has the name from Franz Kafka, who is a writer, we decided to take a spin on that one. And what is the core thing that writers used back then? It was ink. So what we said is this project will be called Inkless.
Inkless, okay.
Because it's the same thing as Kafka would write without ink. And it would use a new mechanism to persist its main writings. So we said, okay, what if Kafka itself wouldn't use disks? So the disks were ink in this analogy. And when we needed to upstream the proposal, we thought, okay, what can we use that is not inkless? And we wanted to play with the less part. And then we were always saying that ink is like the disks for Apache Kafka. So we end up saying, why not diskless? And that's how we got into that place.
Okay, I get it. So so here we are with a version of Kafka where the disks aren't your problem. That you're trying to open source, right? Now this is a commercial angle I don't understand, because the WarpStream you mentioned, they recently sold for a very large amount of money. Reports vary, but the very large is consistent, so that one Kafka company could have diskless storage. We were at the artist formerly known as Kafka Summit last week, and that had, I don't know, something like 4 or 5 companies who were saying they could do diskless Kafka. So there's obvious money and commercial interest in developing object storage for Kafka. Why are you trying to open source it? I mean, it's great that you are, but why? What's the angle?
I will speak first on the commercial motivation, and I know Joseph probably will have something to add there. But we were thinking very long about how we will approach this diskless mechanics, right? So the core breakthrough here is delegating the replication mechanism to the object storage itself, right? So that was kind of like the core idea. The how was actually quite unique to us, simply because when we were discussing, someone raised the hand in the room and said, hey, we at Aiven, we are not running a fork of Kafka. We are running Kafka. We are Kafka. So our version of Kafka is whatever Kafka's version is actually in the open source. So why would we actually try to fork and try to kind of like split the protocol even further when actually the very thing which makes us successful as a business is suffering? Right. So we actually went several rounds, and we came back with the conclusion that if we actually donate this core primitive back to the community, and obviously if it's accepted and everything goes well, right, this will help us go forward. Simply because our model is relatively simple. We believe that if the price is actually good and the quality is high, a lot of businesses will choose for us to manage their Kafka, right? So it's not just about the features, but kind of like ease of use and ergonomics, reliability, partnership, and all this. So this is like the core motivation for us. We don't see any value in withholding a specific feature. There will be no enterprise version of Diskless. Let me put it this way, right?
Okay.
So there is no point for us to actually have this.
And you said Josep had an angle on this too.
So, historically speaking, I've been the director of the open source program office at Aiven. And the fact that Aiven was having so much emphasis on open source already tells you something about it. The mission that we have at Aiven, it has varied through the years, but it has always, except on a brief period of time, contained open source in it. And the idea is always to be the open source data platform out there. Now it's AI-ready open source platform for you. So what we always do is we don't try to keep people in our platform, in our projects, just because they kind of run what we run elsewhere, or that we are sequestering them and not letting them choose the best provider for the technologies they need. We don't believe that's fair, and that's how the business has been made since the very beginning. And obviously what we did was, what if we don't need to maintain that fork, hypothetical fork? Maintaining a fork is extremely complicated and hard. And no matter what you do, and no matter how many people you dedicate to it, you will always miss parts. You will always have merge conflicts. You will always have struggle and reconcile these two walls that are...
You'll always be behind the leading edge.
Correct.
Yeah.
So you need to make that decision. So all these companies we've seen at Current, previously known as Kafka Summit, you could see that they were running a version fixed in a point in time from Kafka. Yeah. If you are lucky, because some of them are complete rewrites just using the external API of Kafka. That means that they always need to play catch-up game with Apache Kafka. And what we thought was, what if we do it exactly the opposite way? Why, if we are not doing a fork at some point in time, still there, and just need to play catch-up game, or we start from an empty shell that is the Kafka API and start implementing things? Why don't we start from Kafka itself? And we elevate Kafka to speak the new cloud primitives. And I think that's the first step in the path, probably. Kafka knows disks, and disks are an essential part of Kafka. You know, the concepts are baked in really in the broker. Yeah. What if we elevate Kafka to be ready to learn and use those cloud primitives that are now available for us?
This makes me wonder, I was going to bring this up later, but maybe this is the right point to do it, in that we are entering this world where disk is infinite, cheap, and abstracted, right? Do you think these days, if Kafka were a new project starting today, that it would start with that kind of storage and maybe add in SSDs as a later feature?
It's a philosophical question, and I'll give you my philosophical answer.
Okay.
When we were trying to explain to the wider group at Aiven, like, what are we doing with diskless topics, right? And what's our approach here? I started with, as I call it, the problem behind the problem. Kafka's replication is not broken. It's actually been a very, very robust mechanism which made Kafka so popular. It's great to the point where I still do not see a very much use in active clusters in the cloud. It's just like so good at retaining and providing the durability guarantees that you seldom see the need to go the extra mile, right? However, the problem behind the problem is that this very replication model is just taxed. There is a way to figure out how to kind of make it more expensive with the ingress and egress and the inter-AZ fees. Now, what we are trying to do here with the flexible replication path, or delegating the replication path back to the object store, is just making sure that the Kafka can survive this pricing model, this kind of like cloud economics model. It's not like trying to introduce a better replication, if it makes sense.
Right. Yeah. This is seeming like the implementation is a big technical challenge, but the motivation is not technical.
Correct.
In fact, from what you're saying about open sourcing it, the aim is to try and keep the technical edge as small as possible. right?
Well, not only. What if tomorrow, for example, EBS gets a magical, like durability guarantees and cross kind of like regional replication and cross-zonal replication at a fraction of the cost? We should be able to kind of like take advantage of this. Kafka should be able to take advantage of this. This lifting and shifting model, like from the data center, and actually make no mistake, Kafka survived 2 data center generations. It's having a very hard time surviving the cloud economics, right? So because of the overall model, we kind of like figured out that if we power Kafka with a flexible replication, this will open up the doors for even what's streamable. Not only the ergonomics we will gain, not only the elasticity, not only the cost, but maybe we can actually unlock this latent demand from customers and from high scale streaming, which kind of like held back because of the economics or held back because Kafka just becomes expensive for certain things.
Yes, yeah, it's related to something I think of as Tustain's law. If you halve the price of something, it becomes 10 times more appealing.
Hopefully, this is the end result. Yes,
Yeah,
exactly.
Yeah. Okay, so let's dig into the technical part of how you do this. Because I was thinking through on the back of an envelope how I would change Kafka to use optionally the existing block storage or object storage, right? That's hard. A large 10-year-old open source project that you want to not break anything but completely rewrite the way it stores data. I'm trying to come up with a naive headline summary that we can talk about, but I'm lost. How do you begin to implement that without breaking things?
So we had clearly the picture where we wanted to start. We wanted to start at the open source project, and we said we are now creating a fork just to play our experiments there. The fork needs to be in trunk. So like at that point in time, it was 4.0 in the making. So we basically, our baseline data was Kafka 4.0. And we said, and we want to have minimal merge conflicts. And that's basically the goals we set for ourselves. And I know that that's awesome, and every single project should be like that. But then it was, okay, now let's try to make it happen. So then we went into a discovery journey and trying to find out, okay, what we need to change, where we need to change that. Because Kafka has 1,000 million layers where you could inject something.
Yeah.
And by the way, after we threw our kip out there has been already 2 more kips, Kafka improvement processes that are applying the same mechanism, not the same mechanism, but basically they are bringing the same capability to Apache Kafka in one way or another, which is talking to the object storages. And that means that there was need for that. We just needed one crazy group of people who did the first step, and then some other ones followed back. So what we first looked at was at the storage, because that's the natural place to look at. The storage is already dealing with tiers. It's already talking to PIA plugins, to object storage, for example. So it was the right place to start looking at.
Because you've got this system, if I can explain just briefly. So you've got this system where the recent data stays on SSDs, and the old data gets archived off to object storage. And that came in maybe 2-3 years ago?
Exactly. Was came in 3.6 as a graduated initiative or feature. And I think it was roughly 1.5 years, 2 years, something like that. Time is a blur sometimes when you speak about versions. I know exactly the version. It's Kafka 3.60. So I can tell you that thing clearly. I know
that's a better timestamp than a timestamp, right?
Exactly. It's exactly that one. I know it by heart. So, and pain, probably. So what we thought is, okay, can we do something in that? The problem is, even if you aggressively tier, you will still have local disk, and you will still need to have the cross replication, because the data that is not yet stored into the storage needs to be persistent and durable, guaranteed to be durable only via disks. So then you need the replication.
Yeah.
So no matter how aggressively you tier, you still pay for each single byte that comes in. You need to pay several times for the replication.
Yeah.
So that was not the solution. And then start messing with the active segment was quite a heavy thing to do. And when you start adding bigger latencies to something that is expected to have almost no latency, you start thinking, I'm asking for trouble. So probably that's not the way we need to look at. And what we did was go several levels above. And we decided to do something, which is, can we do it opt-in and opt-out per topic? So can we create a new type of topics that will follow the classical rules of Kafka as we know them? But on the same cluster, can I create a new type of topics that whenever I write there, I'm not following the normal laws of Kafka, but I'm using the object storage as a native tool. So that means that quite high on the branch of basically the broker, on the decisions that the broker does to write things and to persist and modify and operate any single operation, we did a divergency there by extending existing interfaces and reutilizing as much code as we could, moving a couple of things around that with writing not so much code as one might expect. So we didn't need to write the whole broker. We just need to write some thousands lines of code to be able to have all these mechanisms, including some organizational components and the plugins to write to the object storage. So what we did was branch out. If that was the case, if you are in these specific types of topics, then you don't need to do certain things, like replication is for you useless. You don't need to do replication. Forget about that one. Treat it as replication factor 1.
Right.
Now we can follow down, and then instead of talking to these synchronous APIs to write to disk, you will need to talk to then asynchronous APIs to talk to the S3 or to the any object storage that you use. So we needed that was our way of thinking. So how can we make that parallel path so that no matter how long it takes to merge this project upstream, it will always be an easy path. Because the code that adds this capability sits quite isolated on the side, and it only extends the right interfaces. And there is not so much duplication of code, just a tiny little bit that can be solved by refactoring Kafka code in the upstream project.
So you are keeping the existing mechanism entirely, and so you're not just going into existing code and changing it so that it has. That makes sense. I'm trying to think now how this will play out, because I write some data to a transactions topic, and that's on my usual object storage thing. So that just goes down one branch of the magical if statement. Nothing's changed. Now I'm writing something to pick something less important, clickstreams, a clickstream topic, and that I want on object storage because it's just cheap archive data. So now that's going into something which isn't going to be a leader. It's putting that data to object storage. The first problem I see with that, I'm sure there are going to be lots of problems, but the first one that comes to mind is I don't want to write to object storage every time someone hands me some data because I'm paying per put, right?
Correct.
So I think you're going to say something about batching, and then I'm going to say something about reliability if the crash mid-batch. Explain that to me.
So that's exactly what we're going to discuss right now. So one of the reasons what you want to do is I'm getting one single message, and I don't want to put that message up there. It doesn't make sense. It will be economically or astronomically expensive. Let's forget about that one, right? So that didn't work. So what we wanted to do then is group them, aka batch them. So if I want to use batch, I will use we group them, and then it sounds fancier or less. It's the same. It's in the end the same thing. So what we do is group it either by time or by size, whatever happens first. These two thresholds are configurable. However, we did some studies and analysis on how much time or how much size it makes sense, and where the value, it's basically diminishing returns, where it makes no sense to increase or decrease because it's either too much, so expenses go high too fast, or at one point in time they go down so low that it makes no sense to change any value. And we found that 250 milliseconds and 8 megabytes are roughly the right number, where the more you add, the less benefits you get. And if you are making them smaller, for general use cases, each use case at its own, obviously, they might be getting bigger increases that are not linear. So it's a logarithmic curve.
Yeah.
So that's one of the things we do. But what we decided to do as well is like, okay, now a consequence of delegating everything to the object storage, as in the storage and replication factor.
Yes.
It means that we can go without leaders.
Because Amazon or whoever are doing your leader for you, essentially.
I don't exactly. So I'm writing to S3. S3 will make sure that the thing is replicated. That's the one that needs a leader replica work, and they have that one, and they have plenty of nines.
Yes, it's very battle tested by now.
So why do I, in my project, need to do extra work that will increase the cost of my operation when the place where I want to write it does it already for me? It makes no sense. I'm paying double for the same concept, and we shouldn't be doing that.
Yeah, I'm with you so far, but I see two problems with that.
Yes.
I'm writing to something which is talking to S3.
Yes.
That could crash and lose my data, which hasn't gone to S3. Also, it could crash and then I have no leader, right?
Correct. And if it crashes, so let's think about the first one. What happens if it crashes before it's getting persisted on S3? By default, how we configure it to work, and by the way, we are working on improving that piece because that's one of the weakest points right now, but we are working on making it slightly better. Right now we have an ACK all, basically. So what you need to do, you wait until it's replicated to say that it's written, right? So that's how replication works when you say, I want all ACKs or all ACKs basically received. I'm sending the message, and only until every single replication factor, so I have replication factor of 3, so every 3 brokers say it's written, I will tell back it's written. So we behave the same way, as in ACKs all, I'm writing, and only when it's written in S3, I can tell you that it's written. Obviously, that creates a lot of lag.
So as the client, it's my job to make sure I've got hold of that data and can resend it until I've got that ACK, which is exactly the same way as the previous version.
Exactly. So that behaves the same way, as in, unless if there is any problem in between, I cannot ensure that it's durable. So I, as a producer, as a client that produces the data, I need to retry. It's the same behavior with a different timeline. What we are working on as well is on, can we add mechanisms for accepting ACKs1 so that only when it's persisted on your own node, which gives you plenty of, really not much guarantees, because if the node dies, then the data's lost. It's not being replicated yet. So you know that it's probably there unless there is some problem. We could replicate that mechanism the same way, as in only when you push it there, we hold that data to batch it and push it to the S3, but we can tell you that as long as it's in our memory, it's in there. It's as risky or slightly riskier than what we do right now with ACKs1.
Yeah. Actually, I just want to highlight something which we found out after the fact here, pun intended. ACKs1 is probably the most used kind of configuration out there. So the most workloads today in the world actually are revolving around ACKs1, with some doing ACKs all, right, and very few ACKs0. When we were going into this kind of discovery, we thought that it's far more ACKs0s out there, but actually turned out that it's not. Even metrics and logs and some other things nowadays require at least the leader to say, yeah, I got the data, proceed. So this is kind of like one of the key discoveries and the focus of the next research step for us here.
Right. Yeah. So just to recap that, make sure I've understood it. You've got this mechanism where you can say, I want to wait until I've got confirmation from all 3 nodes that my data's been written before you tell me it's been written. That's one configuration thing. The other is, as long as someone's written it, that's fine.
Yeah, correct. And that's the ACKs1 or ACKs3
Yeah.
That's basically the difference between those ones. And then X0 basically means, yeah, sure, I don't really care that much.
I'll be generous and say that's the Erlang approach. Throw the message across, and if it crashes, it crashes, right?
Yeah.
It will crash nicely and gracefully and with a lot of fireworks. So,
but you said about 2 minutes ago the difference here is lag, and that seems to be an important difference.
Correct. So if you wait on an X3, for example, on any normal classic Kafka setup, you would need to wait until that message gets into one broker, it's written, goes back, another one goes back. So you need to wait until those two messages go back and forth in like simplifying a little bit and all the stuff. But that's what you need to wait. And that's network traffic. Should be okay fast. But now if we are considering that we need to group something, and then we need to talk to S3, we're talking about two sizable lagging operations.
Yeah, you said 250 milliseconds-ish on the batch, and writing to S3 can be variable, but let's call it another 250.
Exactly. Roughly that one, right?
Yeah.
So what happens is, first, if you remove the batching, you still would need to pay the 250 no matter what. But then if you do the batching, and then you can start making maths and try to do the medium case, the best case, worst case. So in the worst case, you need to wait the full 250 milliseconds, and then you write the 250, let's say, to S3, and then you get back. The counterintuitive aspect of that one is that the higher the throughput, the less you need to wait. So the bigger the throughput you have, the bigger system you have, the less delays you're going to do on waiting to accumulate the 8
Is that
megabytes.
Because you were saying 8 megabytes. So if you fill up for 8 megabytes, you don't bother waiting the full 250 milliseconds. Yeah.
So intuitively, when you think like, oh yeah, on the smaller it is, the better it works, and the bigger it is, the bigger the delays. That actually is not the case with this particular instance. It's kind of reversed. With really small and tiny workloads, you will need to wait lots of time because you will never hit the 8 megabytes, right? So you will always need to wait the full time because you are not filling up the bucket in that sense.
Yeah.
The bigger the load you have, the faster you can have the bucket full, so it makes sense and it's worth already pushing it to S3 or to Google Cloud Storage or any other object storage.
And actually, the unit economics of Diskless is also weird. And this is dictated by the cloud itself, that at very low throughput, say a couple of megabytes a second, you're always better off with the classical replicated Kafka. And this is when you start actually getting the more benefits at a certain point. So it's kind of like almost inverse curve at it in this sense, simply because it's not great at low throughput. It gets better the bigger the throughput if you tune it properly. So this is kind of like one of the discoveries we also had, that it's really made for bigger workloads to begin with. It's kind of like works very naturally at those like higher levels.
That sort of makes an intuitive sense, because you wouldn't generally use object storage for tiny bits of data, right?
Yeah,
it's for storing chunks, not scraps.
Yeah,
and
okay.
And also usually what you would like to keep in there is all that massive amount of data that comes, as you said before, all the click data, all tracking devices, for example, the IoT data. That's also one example that I often share is like IoT. When we go into the massive IoTs, that they are not just machines in my home, but rather in the whole country, scattered around on the windmills, for example. Those ones, sometimes they have no signal. They don't send any message anyway. They don't send anything. They send only when they can reach some signal, and they send a huge burst of data. So what it comes back to that one is like, for those use cases that they are massive in amount of data that need to be sent and processed, the question we asked the people was, do you really need that low latency end-to-end, or you actually don't care? And for most of the use cases, no, we actually don't care, because either we look at the data a couple of hours later, or we already group them in 5, 10, 15 seconds all the metrics, all the data from those 10, 15 seconds, we group them. We don't want to have all single data points. We group them already on our visualization tools. So we don't care that much if there is some sort of delay. We just want to have this huge, massive amount of data at a cheap value. Basically, we don't want to pay premium for that expensive replication mechanism when we can rely on cheaper versions of it. We just want to have that one there. And that's one use case where it shines and where we can see that, yes, it has a price, even though we're working on optimizing and trying to make sure that the price that you need to pay in latency is as low as it can be. But there are use cases where even unoptimized, it fits like a glove, because the whole pipeline is already dealing with 2 levels of magnitude bigger than the ones that we're talking about.
Yeah, I can see that. Is there... I would imagine in the real-world use cases, it's a pretty clear-cut which of the 2 sides of the coin you fall on, right? Most people will either be putting through the kind of quantities of data where it's unambiguously better to put it on object storage, whereas some people have use cases that are unambiguously, this is going to have to be hot disk.
Exactly. And that's why we decided to say, whenever we build this thing, we need to keep both topics in the same broker, because we thought, why we need to have 2 different clusters, one for the low latency ones, one for the high latency ones? Why the person producing data needs to understand suddenly my infrastructure topology to know these specific detail that probably shouldn't be even that made aware for the one producing the data. That should be a configuration value for the one setting up the topics.
Yeah.
And having those ones, the 2 types of topics in the same broker or in the same cluster, makes it easy for one to say, I'm now, this one is clearly that one, this one is Diskless, this one is also Diskless, this one stays classic. And eventually you could even migrate from one to the other one. Why not? I mean, from classic to Diskless, you could potentially do those things. Obviously, migrating from Diskless to classic begs the question as well on how we transport the data that it's in there. So obviously you could download that one, you could mirror make it yourself, but that is slightly trickier in that sense. But
I'm going to guess that you're going to have some system where, at least for the first release of this, you say just copy the data over to a new topic and then migrate that way.
Correct. And that we have already Mirror Maker that does this thing wonderfully. So you have a topic and you can say, please replicate that topic to the same cluster.
And because it's a logical replication, you can go from different types of storage.
Correct.
Yeah. Okay, you've made me think of a very thorny question. I'm just going to hold that because it was one of the things when you mentioned windmills and wind and reliability. I was thinking, does it make a big difference if you have like bursty traffic? Imagine my windmills only send data when there's wind, or I'm a shop in the United States and things are naturally quieter at night in the United States. Do you run into different usage patterns or problems when one segment is going to be 10 clicks and the next segment is going to be 10,000?
So one of the beauties of that one as well is how would you do that in classic Kafka? If you would know that, you would need to bring up maybe 2 or 3 more brokers, and then they would need to align themselves and basically rebalance and again make sure that they are in sync, right? And then they could start producing and working. We don't have the need for rebalancing. We don't have the need for being in sync as a replica. You could basically say, I need more throughput. I can spin up another broker. I could basically could break the partitions and I could handle those ones. Or what I can do is actually just leave it as it is. Because actually, as I said before, the higher the throughput, it will have less latencies as long as basically you can process all the messages that are coming. The only thing that you will see is probably a better end-to-end latency when you have the burst compared to when you have a really quiet moment.
Oh, yeah. Yeah, okay, I can see that.
That's one of the consequences. Obviously, we will need to see which numbers we're talking about, right? So what is the baseline number that we are going to, and what's the burst, and how order of magnitudes bigger there are, because if it's exploding, then we might need to do some, we might need to grow the cluster, obviously. But that's one thing that now you have the capability to grow, add new brokers into the cluster almost at immediate level. So you don't need to wait. The only thing you need to wait is the Kafka broker to stand up. There is no data synchronization. You just have it there, ready to consume and produce.
This thing where when you start a new broker, it has to get itself replicated from the existing live ones. Yeah, because that goes away.
Exactly. So one thing is when you do an upgrade, you can do an upgrade in place. Forget about that. Let's ignore that one. That's not the case. When I want to add a new broker, 3, 4, 5, whatever, the number of brokers I want to an existing cluster, those ones, they have nothing. They have an empty disk. So they cannot do anything. They need to wait until they are in sync. So they become one of the other replicas, and then all the data needs to be sent through the network to reach them. And then once they have all the data, they are in sync. And once they are in sync, they can start serving, for example, customers and things like that. But obviously, all that time now it's gone, because there is no such concept as I need to be in sync. When you're using, obviously, these new type of topics, for the old type of topics, for the classical ones, everything stays the same way as before.
Yeah. But you've basically pushed that problem off to S3 again, right?
Correct. Because they have it, they solved it, right? So why you need to solve the problem twice? It's the same thing. So if you would basically now have a software that solves the problem, and I tell you need to solve it again in front of it, why? So you should basically ask yourself why I need to pay twice for solving the same problem if it's already solved for me.
Yeah. I think probably the answer to that is just at the time it was created, that wasn't an option, right?
Absolutely, and I'm not saying that as bashing Kafka. I'm saying it as in now that we can use that directive directly, and basically Kafka understands that they don't have just disks but object storage. We can remove some of the things that Kafka is doing because they are already done by the object storage layer. So in a sense, what we do with this Diskless is delegate replication and storage to the storage layer.
Yeah, that makes sense. Okay, then let me ask you the thorny question, which came to my mind as you were describing that. What about transactions? There is an existing mechanism in Kafka where I can say, I'll read data from this topic and I'll write data out to those two topics, and I do all three of those things or none of them.
So first we thought, can we deal with transactions later? And when we proposed, so basically we wanted to do the KIP and push it there. And then we thought, okay, let's not delay it for months and months before we have a really huge book written about it. and then we throw it. We said, okay, let's write the minimum corpus of KIPs that we think will make the project viable. And we release those ones. And first we thought, okay, transactions we might be able to ship that one as a version 1 without transactions and then come back to it. We got the feedback, no, we should rather do it right now. So we are discovering, and we have certain things that work already, so you could produce both types of topics at the same time. Transactions, we need to check a couple of things if they work, and then we need to tune a couple more. But basically now we cannot say that's a problem of our future selves, is a problem of our current selves, and we will need to deal with that one. So right now, the KIP doesn't solve that. It basically says most of the mechanisms should work on transactions, but some of those ones might work. So idempotency works, but transaction might have a couple of flaky areas or not so pointy areas, let's put it this way.
And actually, this is a very good question, because while transactions are not supported, that doesn't really prevent people to adopt the Diskless topics, because Diskless is Kafka. So if you find that Diskless topics do not support specific feature, in this case like transactions, just go about your day upgrading like any other version, right? And when these become available, you can actually go back to using Diskless topics by simply just creating yet another topic. So this is not like asking the customer, or in this case, like the open source user, to completely lift and shift their estate to something else, or even worse, fork their estate to keep some of the Kafka topics on whatever Kafka they're using and then go on to some other system. They will just continue using the same cluster with the optionality to have Diskless. And this is extremely powerful, and we did it with a lot of intent, simply because we wanted to experience the same upgrade for our own fleet going into this innovation. We wanted to make sure that everything is trivially to upgrade to begin with. Yeah.
It must help having a large existing customer base using Kafka for like checking statistically how this is going to work in practice and that kind of thing.
Yes.
It does.
Well, they keep us at night, right? It's a lot of work, and this is probably the time to say kudos to the whole domain, keeping the lights on, working on this. It's been an insane additional workload for us to get it out of the door, because as I like to say, the work actually just begins, because we started kind of like making the in-works to roll it out within our own fleet. And the beauty of this upgrade path is that we probably will decide to quietly upgrade everyone, even though they don't know, and just keep the business topics behind a flag, so we can activate it opportunistically. Yeah.
Until now that Filip opened our plans to everyone in the world, because they will listen to your podcast and then they will know that. But
you make it sound so nefarious that you're going to upgrade them behind their backs, but that's the whole point of cloud services, right? Someone will upgrade and I would never have to. Upgradeless. It's upgradeless.
Upgradeless.
Yeah, exactly. So we have another name of a product.
Great.
If you think about it, this one shouldn't be that different as of Kafka 4.0 in API levels. So if you update from 3.9 to 4.0, that's the same cost and complexity and problems. You will have exactly the same ones upgrading to Inkless, because Inkless and 4.0 are exactly the same thing. So it's exactly the same.
Right.
And no zero cost. The only thing you need to know when you have the new like Diskless implementation is that you need to set a couple of settings, and when you create a topic, you have a new optional to decide if the type of the topic, if you want to have that it's a Diskless topic or not. If you do nothing, it's a classic one, obviously. So, and that's the only change on the APIs, and backwards compatible change of the API, so everything works if you don't touch anything. Only if you add this new parameter, you create the new type of topics. And then a couple of settings, configs, that's trivial as well. So yes, technically speaking, that's an additive change that needs some client modification, but it's an additive client modification and never a breaking change, backwards incompatible type of.
Okay. Just to clarify on that, if I go and create a new object-backed storage topic, right? So different flags when I'm saying create topic. But then when I go and connect my regular client software, and let's say it's not the Java one, let's pick the JavaScript one, because that's not exactly, but it's broker protocol compatible. Me writing code, will I notice any difference other than latency?
Only latency. And that's the beauty of it.
Okay.
Producing and consuming, you need nothing to write to that type of stuff. There is nothing else. It's a topic. And that's the beauty. So we decided to be really, really conservative on number of changes towards the end, as in end user, because we didn't want to increase our surface of denying the feature to the upstream project. The more you modify things, the more you change current behavior, the more the resistance you will have, obviously, to get any change in, because it's a breaking change. It touches too many moving parts. So we wanted to change as few moving parts from the outer layer as possible, because nothing. If you need to rewrite all the libraries in the world, you will never finish.
Yeah, that's a mountain that's too high to climb. Right?
So the only thing that you need to change is when you create a topic, you need to pass a new flag. That's the only thing. That's the only change that needs to be done, which, by the way, can be done by command line with the shell script that we all know in Apache Kafka. So we modify that one. We can do this one. And as a proof of that is that Aiven is a Python company. So they use the Python client, and it works.
Okay.
So the biggest problem we had was between 3.9 and 4.0, not between 4.0 and Inkless, because the library we were using was still speaking old protocol, message protocol, so that those were dropped in 4.0, and that was the biggest change we needed to do, and it was from 3.9 to 4, not from 4 to Inkless.
Okay, yeah.
Diskless. And by the way, I'm saying Diskless and Inkless every now and then because Inkless is the project we open source that implements, that it's an implementation of Diskless. And that's why I keep saying both, not randomly. I was trying to be precise.
I think I got that. What you don't know is every time you say Inkless, somehow I think of Octopi.
Oh, okay.
Okay, it's popping up in my head every time you say Inkless, so that's out there now.
It's the same thing. So when we were looking for a logo, the first thing that came to my mind was an octopus as well.
And then you thought about being sued by GitHub.
No, the problem is we have already an octopus as a logo for one of the projects at Aiven, so we couldn't use an octopus for that.
Okay.
Yeah.
Even though the GitHub is an octocat.
It's an octocat. I'm not sure if the courts will recognize that distinction when they try and sue you.
Well, it's just to kind of like prove what Joseph said, when we set out to upgrade our kind of like one of our products, it's called Bring Your Own Cloud, doesn't matter. The compatibility was so strong that a single engineer took approximately less than 4 weeks to get it up and running. This was just to kind of like update the automation, and most of the stuff was like the automation shouldn't do, right? Like don't look at the disk, don't look at the replication progress, don't look at this. So it was extremely boring exercise the moment we actually started onboarding our own Kafka to Diskless. It was very, very interesting how quickly things actually go when you have rethought from first principles that you don't really touch the API surface.
Yeah, that's the good kind of boring. We like that kind of boring.
Yeah. And what Filip was saying, like one of the problems of the new type of topics is there are plenty of tools out there that they open the hood of Kafka and they start looking at the internals on the state of the internal and start looking at how are my replicas, how are they in sync, are they not in sync, concepts that we destroyed for the new type of topics. So obviously that's the thing that we would need to tune or modify, and that was clear for us. Obviously, when you try to change how things work internally, every single project that goes and looks inside will need to suffer a little bit. And
this is going to change the monitoring world for Kafka.
Correct. The monitoring world that it's really built in and has smart metrics and smart even actions or recommendations, that would need to be relearned or they would need to be excluded for these type of topics.
Yeah. I can see that starting to percolate into the Kafka-related monitoring tools anyway, because there are so many companies pushing in this direction that surely they're reacting to that.
Yeah.
Okay, so no client-facing changes, but there is a large chunk of this we haven't discussed how it works under the hood in the back end. We've talked almost exclusively about reads. Does this change the write picture at all? Sorry, I've said that the wrong way around.
Yeah.
We've talked almost exclusively about writes. Does this change the read picture at all?
So the read picture has the counter problem of what we were talking before. When you produce, what we said is producing one single message will be prohibitively expensive, so we needed to batch them and group them and send them. Similarly, if I'm asking for one message and I'm going to S3, come back, serve it, and then you come again and you ask again for the next one, and you need to go back to S3, you can see that will be crazy expensive.
Yeah, you're going to start looking like something like a paging algorithm in an operating system, aren't you?
And by the way, that's what in a sense, that's what the TH storage plugins and the TH storage mechanism did already in the past. You have the offsets. You need to go to S3. So you have the offset management that needs to know where exactly in the S3 vault located is. And then when you fetch, you don't fetch just one message, but you fetch a group of them that it's big enough. You put it on your caching memory and you serve from your caching memory. You don't need to worry about that one. So the problem that comes as well is when, and now I will showcase that I have back pain and I'm slightly old. Windows defragmentation disk, if you ever remember running that one. Do you remember
I'm far
that?
too young to remember defragging disks.
Yeah, exactly.
But let's pretend I remember exactly what that is.
Exactly. Let's pretend you don't need to go to the doctor every year to check your back, and you do remember this. What happened? You were optimizing for writes, but at one point in time, optimizing for writes made it that reads were really slow. And then you needed to go and do a defragmentation. So you need to reorder every single blob, a sector on the disk to be written in the proper way. So then files were contiguous and not just broken into different parts.
Make sure that everything that sits together logically sits together physically. Yeah.
Yes.
And in a similar way, that's one of the mechanisms that we propose is when we write on write effectiveness. So what that means is that you could potentially say, okay, I have data from this petition, also from this petition, they're written in the same broker. I can group those ones in the same object to be sent to the object storage, and I can push that thing there.
Right. Yeah.
So I'm grouping things that probably logically might not make sense, but it's really good to get that. You remember the throughput megabytes that we were talking about before? If you reach them, you don't need to reach them on a single partition or a single topic. You could basically say, if I'm reaching them on that broker on any diskless topic, then I will push them up, right? So that's on writing optimization, but then for reading, you want exactly the opposite. So one point in time, what you need to do is go and read all the messages that they are entangled and detangle them and put them into the right ordering. So when I'm reading and I'm fetching data that is old, I'm getting all data that it's useful for me. Because when I'm reading that offset, I will probably follow with the next one and the next one and the next one and the next one. And what I want is data locality when I'm fetching.
Yeah.
But that works nicely when you're reading old data or stale data, quote, quote, like data that is
like
not
archive data.
Exactly.
Yeah.
But if you're reading data that it just happened, you will have a lot of consumers that will read the data as it happened. So probably that optimized storage organization might work already for you, because the consumers produce more or less. You're producing and you consume as soon as they come. And
yes, they're kind of grouped logically by time in that sense. So
correct.
That probably is what you want to see first out.
If you are all reading the same pattern that you're writing and always keeping up more or less with what's being written, probably the right optimized writing is not that bad for you. But when you go back in time and one consumer, now I need to read all my historical data, then yes, I will read a lot of data that I don't want to even know about, obviously, like fetching from S3. So I would need to fetch a lot of data that's discarded. That's why we have this optimization, this recompaction, or basically resorting of the data so it's useful and more effective for reads.
Yeah. Now that has made me think, because if I go and defragment my storage, I think that's going to be fairly straightforward, because I read a bunch of files. Once you've put the storage, it's kind of it's write once, isn't it? Write once, so I can read stuff back, confident that it won't be updated while I'm reading it.
Correct.
Put it all together in one thing, write that back, and then tell my metadata layer, forget those 4 blocks, there's this one new block, right?
Correct.
And that makes me want... So that sounds great and straightforward, but metadata layer, where are we writing this metadata? And what are we doing about the durability of that? We skipped over.
And I was about
You
to
thought
say,
you could catch me out.
No. And I was thinking, we are not talking about batch coordinator yet, and it should come. So obviously, the piece of the puzzle that is missing right now is that one. And we now need to tell you that, so the KIP proposes one thing, what we implemented is another thing for now because of convenience.
Okay.
So the KIP, knowing that that needs to be upstream to Kafka, we need to find a Kafka native solution. And what's more native to Kafka than topics themselves? So you would manage the offset management, or basically the batch coordinate. The thing that translates that offset is in that coordinate on the object storage will be backed by a topic. That's being heavily discussed. We have several options and several possible architectures on how we can save that and how we can process that and structure that and how it scales up and down. Each of them has its own advantages and disadvantages, and we were thinking about as well, do we follow a cell architecture or not, or we just have one single partition, or we have several. So full of discussions on what's the most optimal way of doing it. No matter what we do, if we are going on Kafka, it's obviously on a classic topic and the default topic. It's as suitable as Kafka itself. So technically speaking, Diskless would use classical topics to maintain durability of the metadata.
Okay.
And that's the metadata, as in meta. In this particular case, it's the metadata. And what we say is that what we want to do is remove the disks for the data layer. The metadata layer is tiny.
Yeah.
Right. Yeah.
It's not worth it to go into the business of removing the need for having storage for the metadata. The returns of that will be so narrow and tiny that it probably makes no sense. And
actually, yeah, we actually have some numbers already because we are using it internally. And under sustained load of circa 100 megabytes a second, right? It fluctuates because we actually hooked it up to a live service. The most we saw actually was 36 megabytes. So this is almost negligible when it comes to local disk used. This is for the
megabytes of metadata?
Of storage. Correct, yeah, that's it. Yeah.
Total or?
Total, yeah. This was actually total usage, so spread across. It's almost negligible in the grand picture of kind of like stateful system like Kafka.
Okay.
And as I was mentioning before, that's the thing that's the version we want to upstream to Kafka. What we implemented to basically get something quickly out of the way that we knew that it would work, but it would never be merged upstream. It uses a Postgres database.
And we happen to sell a lot of Postgres as well. We know a thing or two about Postgres. Yeah,
it was convenience, and we had Postgres around, and we knew how to deal with them, and so we used them. So we used that thing to just basically get something out of the way to get it quickly. We knew that going into a Kafka native management of the batch coordination would be quite controversial, and no matter path we took, we would need to take another one probably, or a modified one, and it's a complicated problem. So we decided to take one step back and say, okay, for ourselves, we can run Kafka with another thing. It's fine. For the open source version, it can't be like that. Then you have a Postgres instance over there that is the one that stores this data. And how durable it is, as much as you can and as much as you want. So you can have several replicas. You can have a RIP replica that is synced all the time. You can have constant backups, wall backups with full backups every now and then.
Yeah.
You choose.
The purist in me wants it to be all Kafka. The realist in me sees why you made that decision.
So we will eventually go to the whatever implementation we agree on collectively as Apache Kafka community. But in the meantime, that was handy quickly, and we could get this thing out of the way. So we got ourselves with that out of the way.
Yeah, makes sense. You have to be practical and aiming for beautiful.
Exactly.
Yeah. Sounds like married life somehow.
something.
Yeah. I'm criticizing myself there, but so this is the big thing that we haven't dived into. Then you have a working implementation internally at Aiven. You are working hard to upstream into the open source model. How's that going? What's the status? What's the challenge of getting that done?
So we have basically a project into our Aiven organization. So if you go to github.com/Aiven/Inkless, like the octopuses we were mentioning before, you can see the code there. It's purely a Kafka 4.0 baseline code with plenty of commits. And you can go in the history, you can see every single step of the way. We didn't hide anything. We didn't obfuscate any commit. We just programmed in the shadows as if we would be programming in the open, because we knew that we were going to open that one eventually. Right. So we just went onto that mode. It's all the history is there. That's the project that we have. It's implemented there for everyone to see. We don't want actually people to contribute to that project because we don't want to create a split community. We don't want to now people start flocking around this new project and start saying, oh, I'm using this one instead of the other one or anything like that. We want, if people want this feature, the right thing to do is push for that feature to be in Apache Kafka.
Yeah.
Otherwise, we are not in the business of creating another Kafka competitor. That's not what we want. We want to have Kafka having this feature. So the first thing we did was create a KIP, which is the Kafka improvement process. And we started with a motivational question, which is skip 1150. And I paraphrase, but it's basically saying, do we even want Kafka to talk to those new cloud primitives like object storage? Because we've seen that there are 7 different forks out there. Some of them proprietary, some of them open source, but they are forks of Kafka that have this capability. Do we want the mainline upstream Kafka to have this one? And that's 1150. That's the keep 1150. And then 1150 says, and if you want that, we have ideas and we have an opinion. And please go read our opinions. And we separated instead of having 1 mega KIP, we learned from TH Storage, aka 405. It took 6 years from writing to 3.6.
Was it 6 years?
Yes.
Crikey. Okay.
So we learned. So I checked. I look at the history of what happened. I'm not saying I have the keys of why things happened the way they happened, and many different complex things happen at the same time. But one of the things that comes to you directly when you read KIP 405 is that it was a huge, big explanation of what is this feature doing. And that makes discussions, because in case somebody doesn't know how proposals work in Kafka, you need to write a proposal up front. You write it up front, exactly every single change you propose, with migration paths, with testing strategies and whatnot. And then you open up for discussion with the community. Once you reach a consensus on the discussion, you open it up for a vote. And then you need 3 + 1 votes at least. The vote needs to be open for 72 hours. And in the end, you need to have more +1s than -1s votes.
Right.
And the votes that count, let's put it this way, are the binding votes that they come from maintainers only. The community can vote, and it only expresses
sentiment, but not power.
Correct. It's basically expresses willingness of the community to have that one. So I would really wonder, it never happened, if the community would say +1s in mass and maintainers would say -1 in mass. That would be a really weird situation where the maintainers kind of go in an opposite direction of where the community wants. But as I said, it never happened. But
imagine it's happened in geopolitical history. But
absolutely.
Let's not touch that topic. Why did I bring it up?
So open source sometimes is more geopolitical discussions than technical discussions. So what we decided to do was, instead of having one big, huge discussion that is it's a totality discussion. It's either I'm agreeing with the totality of the proposal or I'm disagreeing with the totality of the proposal.
Oh, right, yeah.
So what we did was, can we break it down into areas that are replaceable, if that makes sense. So we have a core KIP, which is the one that explains everything. But the batch coordinator is another KIP. The core implementation needs a batch coordinator. If it has A, B, C, D, or F version, we don't care in that sense. I mean, the feature works with a version of that. It doesn't matter which one. It's one.
You don't want the whole discussion about the overall feature to be blocked by a legitimate concern about the way you're writing metadata.
Perfect. Yeah. And then you isolate discussions where they matter and where they can be precise, concise, and as long as they need to be.
Yeah.
Because they might need to be long, and we might need to go through 1,000 million places, and that's perfectly fine. But our approach was, can we isolate discussions so they are meaningful, and every single thing that is discussed is to move the feature forward and not just to stall or block other parts when half of it could go forward.
Yeah.
And that's one of our attempts on how we can make that happen faster, probably, or how we can make it more palatable for people to review, understand, and agree to those proposals.
Yeah.
We basically, we don't want perfect to be the enemy of good. That's really like the intent behind all of it. And I think it has worked rather well so far, because it's kind of like still we are very much on track to kind of like discuss, do we want it, right? Is this the right place? Is this the right approach to actually having Kafka speak to those primitives, and should actually Kafka adopt this type of a replication flow? Yeah, instead of going into the mechanics of the batch coordinator, for example. Yeah.
Do you find, I mean, I'm just thinking, as you try and make that argument, you said that a large part of that argument is about cost. Does that argument land well in a purely open source project?
That's a very good question. And I was talking to some maintainers as well, in petit comité, so basically behind doors, saying, hey, we have something. You want to have a sneak peek? And that was one of the questions that we got as well. This was, shall we go there? And then the question is, well, 7 other forks of it went there. And a friend of mine, and also maintainer of Kafka, who actually works at Aiven as well, he submitted a call for papers for Community of the Code. And the title is, We Shall Win Kafka Back. Because effectively, if you start counting on number of, as a service, so in SaaS products, if you count probably the number of Kafkas versus Kafka-like clusters that are out there, I think the Kafka-like wins by large.
By sheer volume of use?
Yes.
Yeah.
So if we think about every of the big ones, so if we talk about Amazon, they have their own version of Kafka, which is not Kafka, it's a own variant that it's closed source and nobody knows what they run. It's basically MSK, right? We know that Confluent has Cora, for example, and they have also now WarpStream. Both of them are not pure Apache Kafka. One is probably a modification of it. I just can assume. I never worked at Confluent. I don't know what it is. I only can assume. I know that WarpStream is a re-implementation of the API and inwards. And we have other big players that in the end, what they run is not Kafka itself, but they run versions of Kafka with new capabilities in it. So the question was, do we want to keep that dichotomy and let Kafka just become the gatekeeper of the API, of the protocol?
Yeah, it is starting to blur whether Kafka is a project or a protocol.
And that's our take of, let's make it a project again.
But in order to do that, you've got to look at the reasons why it's forking.
Correct. So going back to why people create forks. So why I do create a fork of an open source project is because I have a feature, I want to implement this feature, and the maintainers do not want this feature at this moment. So I happily take a fork, make that a new path line, and I go over there. But the same beauty of open source that lets you do that, lets you merge back and lets you, maybe now I changed my mind. And now that I see that, those were successful features, let me add it myself. And that's the beauty of open source, that you can say, I made my own copy or my own version. And in a way, they validated that was a right feature to do on Kafka. Because as you said, you started one of the questions that you asked at the very beginning was, why did you open source it when it's clear that there is appetite for the business and companies are being bought by hefty amounts by holding this thing proprietary? So clearly they did something right. That feature clearly is wanted.
Yeah.
And there is business case behind. And that's why the motivational question came. Do we want to close that gap? Do we want... It's our attempt to close the gap and to reclaim Kafka as not just a protocol holder, but a project holder, where the innovation lives.
Yes.
And that's really epic.
Yeah. There are many places in which the project has been at the forefront. In this one, there's certainly a chance to catch up. And there's a fundamental economic reason why there's always going to be that demand.
Yeah.
Yeah, I see it.
Well, it's not only the economics. One of the things which we also need to look at is also ergonomics and a few other things. And I always like to see what's the question behind the question. And even though the motivation question is present in 1150, the real question for us was, if it took 6 years, almost half a decade, for tier storage to materialize, can we afford to have such a feature in the next 6 years? Can we actually have it today? Can we actually have it soon? Can the whole project actually move faster? And I find it always funny that Kafka doesn't have a marketing team, doesn't have a product team.
Yeah.
It has a bunch of ultra talented individuals contributing to it, and a lot of companies sit behind it. But what if we, and at the same time, not having those capabilities, it's still the most dominant deployment form of Kafka, right? The open source version is the most used one, the biggest one, and probably will continue to be such. So the question we actually want to ask is, can we secure Kafka's future for the next 10 years? Because we'll continue building on it. I intend to stay probably for the next 20 years in Kafka. I want to make sure that we have the necessary primitives to continue building. So going back to the motivational question, should we make sure that we take care of our own house so that we can kind of continue building whatever we want to build on top of it?
Yeah. That perhaps leads me to the last question in this, which is, I know as part of this, you're proposing that the batch writing coordinator thing become an interface rather than an if path.
Mm-hmm.
Do you see there being other kinds of batch writing coming up in the future? Or is this just trying to lay the groundwork for abstraction?
I'm going to come back from the product management perspective right now, just for a second, because this is very important. We are not building batch coordinator for the sake of having batch in stream or something fancy. We are building the batch coordinator with the intent to leverage a certain cloud primitive. In this case, is the object store. I already mentioned it. If tomorrow we find a very nice kind of cross-cloud primitive, which, for example, EBS, right? And we don't need to cross zones there, right? And we can just piggyback on EBS. Why not actually figure out a coordination mechanism, right, to actually link this back to Kafka? So the batch coordinator is kind of the result of a problem we want to solve, meaning that we want to bypass all those kind of toll booths of the cloud, as I call them internally, with object storage. But if tomorrow, for example, we have a better or more interesting lower latency or more economically viable cloud primitive in EBS, and by the way, very recently, S3 Express lowered dramatically the prices. So we are already seeing this architecture winning simply because we can flip a switch and now use a new storage class in Diskless, which is S3 Express. And this is much lower latency. It will improve by almost 60% the end-to-end latency, yet it will cost just increment on top of the S3 standard storage class. So this kind of like ability to mix and match the storage classes is extremely important for us going forward.
Yeah, I can see that. So hopefully this doesn't take until 2031 to merge, and you can start taking advantage of all of that.
Yeah.
Do you want to give a prediction, or are you not going to go down that road?
I don't want to give any prediction. That will stay forever, and then somebody will come back to me saying, "Look what he said on that podcast." Yeah. I want to save my future me from myself right now, but I hope. So if I can hope something, I hope that the discussions stay on basically as they have been as of now. They have been awesome discussions and really on point on how can we solve that problem and what's the best way to solve that problem or that other one. And I think the only thing I'm hoping is that these are the kind of discussions we're having, and there is no other type of background discussions or conflict of interest discussions that sometimes have happened in the past in many other different projects. So I hope that we keep that discussion level as it is right now and move forward from that.
Yeah, that makes sense.
My prediction is very, very similar to yours, Joseph, but I will just take it a step further. The real narrative here is that open source is quality. So in many cases, we see companies open sourcing something, but not being around to maintain it, like 2 years, 3 years, 5 years, 10 years into the future, right? Like it's business at the end of the day. So with open sourcing and being extremely intentional that this is upstream aligned and open sourced, it means that you secure the future of a feature regardless of what happens to the original creator. This is extremely important to reinforce this narrative and this kind of like quality feel to the Apache Kafka project. So what I can actually predict is that we will not let go of this feature until it's delivered when this is something for the community to decide.
Fair enough. Yeah. On that community note, perhaps as a final question then, I'm someone with a vested interest in open source Kafka's future. I'm not a committer. Is there anything useful I could do?
Of course. So despite your maintainership level, either if you are no maintainer or maintainer, doesn't matter. If you are interested in that space and you want to give your opinion, go to the discuss threads, go to the vote threads whenever they are open and express your opinion or vote on any of these features. Your opinion matters. And one of the things that I want to raise as a maintainer of Apache Kafka is that sometimes we are in our own bubble because we talk among ourselves and between ourselves about the things we think ourselves, but there is few feedback from the community that sometimes I guess it might feel scary to go to those threads and start saying, actually, I like this feature and we should have that one. And sometimes you see two maintainers arguing why that might not be a good feature because nobody wants it. And
yeah,
and the community might be behind saying, but actually we did want that one. So as a community members, what I would anyone who cares about Kafka, I would say, please go to the discuss threads of this KIP or other KIPs, doesn't matter. The ones that speak to you, go there and share your opinion, share your ideas on what's good, what's bad, what works, what doesn't. And if you like those features to be in there, also share that. That even if it's just, I really love this thing, I would love to have this one in.
Okay, that's what I need to do then. I will do that, and then I will. While I've got the links, I'll stick them in the show notes for this episode.
Awesome.
And on that note, with work ahead of all of us, but far more work ahead for you two than me.
Yeah, probably.
Josep, Filip, thank you very much for joining me.
Thank you so much. Appreciate it.
Thank you very much.
Cheers. Thank you, gents. As ever, links in the show notes if you want to get involved, if you want to review their proposals or critique their proposals, or if you want to check out the temporary fork they've pushed. I hope this feature gets merged in one form or another, but it won't happen overnight. It shouldn't happen overnight. It deserves some thought and care and community input, so we shall see what happens. If you're emotionally invested in the idea, go and check it out. As I said at the start, this episode was sponsored by Aiven, so thank you to them. I have been second-guessing myself all week about any unconscious bias. I don't think there was any, but I'm sure you'll let me know in the comments either way. And either way, if you've enjoyed this episode, please take a moment to like it, rate it, or share it with a friend. And make sure you're subscribed, because we'll be back soon with another episode. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Josep Prat and Filip Yonov. Thanks for listening.